Nuclear Chemistry, Part 4, Nuclear Equations. In this video, we'll predict the new nucleus formed from a radioactive decay. To predict the products of a nuclear decay, we're going to need to use balanced nuclear equations. Balancing nuclear equations is very different from balancing a chemical equation. In a balanced nuclear equation, we will use the isotopic notation to make sure that the total mass number adds up to the same thing on each side of the equation, and to make sure that the total atomic number adds up to the same thing on each side of the equation. Here's a balanced and an unbalanced example. In the balanced example, if we add up the 4 and the 234 from the right side's mass numbers, we get 238, the total on the left. And if we add up the 2 and the 90 from the right side's atomic numbers, we get 92, which is the total on the left, balanced. In the unbalanced example, can you find the mistake? The atomic numbers on each side of the equation add up to 92, but the mass numbers do not add up to the same thing. So either the 238 is wrong for uranium, or the 232 is wrong for thorium. Although, I guess the 4 on the helium could also be wrong, but probably not, because that's the isotopic notation for an alpha particle. Let's do some practice. Here is the beginnings of a nuclear equation that we're going to balance. It looks like we have radium-226 undergoing an alpha decay. What is the other product from this nuclear reaction? To do that, you'll need a periodic table handy to look up atomic numbers and symbols. So, what's the product going to be? I'll give you a moment and then we'll go over it together. Pause the video if you need more than 10 seconds. The total mass number on the left side of the arrow is 226. So, what number will add to 4 to get 226? It's 222. The same thing you get if you think of it as 226 minus 4. 222 is the mass number of the new nucleus formed. The atomic number total on the left is 88, so it's got to be 88 total on the right too. 88 minus 2 is 86, so 86 must be the atomic number of our unknown product. Using the periodic table, we see that the element with an atomic number of 86 is in fact radon. The symbol for radon is Rn. That means that when radium-226 undergoes an alpha decay, it produces a new nucleus of radon-222. What about this one? Can you predict the new nucleus formed from this beta decay of carbon-14? I'll give you 10 seconds, but pause if you need more time. "14 minus 0 is 14. 6 minus negative 1 is the same thing as 6 plus 1, so 7 is our new atomic number. What's the symbol for that atomic number? It's an N for nitrogen. The new nucleus that formed is nitrogen-14. We can double check our work by ensuring that the sum of the mass numbers on each side is the same, and that the sum of the atomic numbers on each side is also the same. Let's see, 14 plus 0 is 14. Check. 7 minus 1 is 6, so double check. Good to go. This problem is a little bit trickier, but not too much. What is the new nucleus formed from the beta decay of potassium-40? We've got the potassium-40's isotopic notation, but we don't have either of the products in our equation yet. Good thing I said it was beta decay, so all we need to do is add a beta particle to the product side, and then we can do the math to determine the new nucleus. Do you remember the isotopic notation of a beta particle? There it is. Now, take a moment to figure out the new nucleus. Pause if you need more than 10 seconds. "40 minus 0 is 40. 19 minus negative 1 is 20. So the new nucleus is calcium-40. I looked up the atomic number to discover that element 20 is calcium. Now let's see if you got this one. Predict the new nucleus formed from the alpha decay of americium-241. I've included the isotopic notation of americium-241, but that's all you're going to get. Pause if you need more than about 10 seconds. The final answer is neptunium-237. The isotopic notation of an alpha particle has a mass number of 4 and an atomic number of 2, so it's helium. When I subtracted 4 from 241, I get 237, the new mass number. When I subtract 2 from 95, I get 93, the new atomic number. Number 93 on the periodic table is neptunium, and its symbol is Np. So neptunium-237 is our new product. How'd you do? Before we go, just a quick note. You may have noticed that our only examples were alpha and beta decays. Since gamma rays are not particles, they aren't going to change anything about the mass number or the atomic number of the nucleus. It's only energy, so the isotopic notations wouldn't change, and that'd be super boring to write equations for. So there. Thanks for watching this video to predict the product of alpha and beta decays. See you next time.